In this problem, we're trying to find the kinetic energy of the alpha particle and a deuteron. If we know that a proton has the kinetic energy of 1.3 mega electron volts and it's moving around in a circle, here's the magnetic field, here is the force, the centripetal force for that magnetic field, and we know that the centripetal force equation would be something like QVB equals mv squared over r for charged particles and stuff, according to the magnetic field cross product stuff. So let's get rid of these v's here real quick, and we're just going to say QB, multiply the r over here and divide that by m. We're going to just get this expression for v. That's going to help us because we know the kinetic energy. We're trying to deal with kinetic energy. We know that kinetic energy is supposed to be 1/2 mv squared. Let's try to put velocity in terms of kinetic energy. So we're going to go 2, divide that by m, and we're going to try to square root that so that we get velocity on this side and that little expression with kinetic energy. So that way we can put that equal to that. So we get 2ke over m equals rqb over m. We'll square everything over here, getting rid of this thing. And then we'll get rid of these m's. We'll just have a 1m on this side. And then we'll divide this thing over here by 2 so that we get this ke equals r squared q squared b squared over 2m. Now, this is basically what we want to start comparing between these three things. For the proton, let's go ahead and write that out. It's going to be r squared and then e squared and then b squared divided by 2u. That's for the proton. For the alpha particle, ke alpha, that's going to be more like r squared. Here we're going to have this squared. So it would be 4e squared, and then we'll have b squared, and then we'll divide that by the 4u on the bottom. It would be 2 times 4u, so 2 times 4u. Okay. You'll note that this will cancel. And so you're just going to get r squared, e squared, b squared over 2u. Looks like those two are actually the same. So ke for the proton is equal to the ke for the alpha particle. All right, that's excellent. We got one of our answers. And now for the deuteron, let's also put that in here real quick. Ke for the deuteron, r squared, q squared is going to be e squared, b squared divided by 2 times the mass, which is 2u. This is going to end up as being basically a 4u on the bottom. So r squared, e squared, b squared divided by 4u. It looks like it's going to be basically kep divided by 2 equals ked. And so now we've got our two answers. We just kind of would want to divide that out. And so we would say that ke for the alpha particle is the same as the proton, so 1.3 mega electron volts. And the ke for the deuteron would be half of that, which I believe would be 0.65 mega electron volts. And so now we have our answers. Interesting.